Look at this, okay? What I have here drawn is a graph of y equals minus x squared plus 5x minus 6, okay? Now, the thing to note about the shape of the curve is that it's n-shaped. It will always be n-shaped if it's a minus x squared. If it's a plus x squared, it will be u-shaped, okay? It's one thing you have to know off by heart. Now, the next thing you got to look at here is the following, okay? You always interpret the graph from going left to right, okay? And what happens is, on the way up, from going left to right, you can see it's currently on its way up. This is described as increasing, okay? So this is increasing. Then, at the very top, okay, it has what's called a turning point, where it's about to go from increasing to decreasing, okay? Then, on the way down, it's decreasing, okay? Now, what we use differentiation to do is we use differentiation to A, tell whether something is increasing or decreasing, and B, to tell whether or not it's a turning point. Now, in differentiation, the first derivative, or dy dx, is a formula for the slope. So, for example, okay, if I differentiate this, now the one thing you got to remember about differentiation, let's go through a couple of simple derivatives with you. Any number where it's minus 5 plus 100 minus 1,000, when you differentiate a regular number, they always turn to 0. Okay, it's the first thing you need to know. Any number on its own will always turn to 0 when you differentiate. Okay, second thing you need to know, any number that has an x beside it, so for example 100x minus 1000x, a half x, when you differentiate it, all what happens is the x disappears. So the answer to the first one, if I differentiate, is 100, next one minus 1000, and the last one a half. Now that's their learn-offs, okay? Once you're done with that, what happens third is when you have a power. So for example, x power 3, x power 4, 4x to the power 3, x squared, and finally we're going to go for, let's say, x, x to the power 5x to the power 6, okay? Now look at this, guys. When you differentiate anything that has a power above 2 or above, squared, cubes, power 4, power 5, what you always do, when you differentiate, bring the 3 to the front, and you get 3x, take 1 away from the power, 3x squared. What's the next one is?
4x cubed.
4x cubed. After that?
12x squared.
12x squared. Because if 3 by 4 is 12, minus 1 is x squared. After that?
2x.
2x. And finally after that?
30x the power of 5.
30x power 5. Okay? Perfect. Now, here's what you need to know. Once you've figured all this out, okay? Once you know how to differentiate, which everybody seems to know, the next thing is remembering what means what. Okay, so for example, when you differentiate this, when you differentiate minus x squared, you get minus 2x. When you differentiate 5, you get plus 5. Now, that's the formula, and the 6 turns to 0, which doesn't need to be included. This is your formula for the slope of the line. So, for example, at any given point, if I choose the point x equals 1, see the point x equals 1? X equals 1 is located here. What happens is, this equation here, it's an equation of a line, isn't it? Why is it an equation of a line? Because it has no x squared or y squared, it just has an x. So, for example, it will give me a slope, a line every time. If I put it in for 4, I'd be expecting a downward slope. So increasing always has a positive slope, decreasing always has a negative slope. So let's check this out. If I put in x equals 2, am I expecting a positive slope or a negative slope for my answer? Positive, because it's going diagonal right up, while on the other side it's going diagonal right down. So look at this, guys. Replace x with 2. What do we get? Minus 2 times 2 plus 5. And what do we get? Minus 4 plus 5 plus 1. Plus 1 represents the slope of this green line here. Okay? It's a positive slope. Now, what happens if we replace it with x equals 4? Can anybody tell me? X equals 4.
Negative.
It's going to be a negative slope because it's going to be minus 2 times 4 plus 5. And what that's going to get me is, what will it get me there? Minus 3. And that explains the slope going downwards. Okay? So, in a nutshell, that's what differentiation is, okay? Can anybody tell me, if I was to ask you, what is the turning point? What's the location of this point here? What's the x value of this point here? What could you tell me? It's going to be 2.5. But there's a way of doing that without doing it by graph. Okay? We're going to get minus 2x plus 5 equals 0. Because what happens when you reach the top? It has no slope. Because the slope is perfectly flat. So what you're going to get is minus 2x equals minus 5. And as Gavin said, x equals 2.5. 2.5 gives you the value of x where it reaches the top of the slope, so to speak. Okay? Huh? And no, it's in between 2 and 3. Do you see by the top of the graphs in between 2 and 3? Okay? So x equals 2.5. Now, what you'll often be asked is, what's the y value then? To get the y value, you have to go to your original function that doesn't say dy dx, it says y. So then anywhere you see 2.5, you enter it in for x, and what that will do is it will give you the y value. Now let's make an estimate. The y value is in between 0 and 1. If we don't get an answer between 0 and 1, we've obviously gone wrong. Okay, so let's check this out. And then minus 6. I got a quarter. So minus 2x plus 5. It's the equation of the tangent line and. Okay, guys. So when I differentiate a function, Andrew, I get this equation here that doesn't have an x squared in it. Okay. This equation represents the slope of any point I want. So, for example, if I went to this point here, okay. I go all the way back up to the x-axis and I realise it's x equals 5. Now what happens is, if I put x equals 5 into the differentiated equation, it will tell me what the slope is. Okay? So, and we know that we're expecting a negative slope, aren't we? Because it's on its way down as opposed to its way up. So what happens is this, okay? We'd get replace x with 5 and we'd have minus 2 times 5 plus 5. And that'll give me minus 10 plus 5. Which is minus 5. So dy dx equals minus 5. This means that the slope is minus 5.
dy dx means differentiation.
Yeah, dy dx also means slope. So what I'm going to do is I'm going to write down a list of things that you need to know. Okay, and this is not in your tables, learned off by heart. First of all, any function differentiated equals the slope. Okay. If your differentiation, when you put in the x value, is bigger than 0, it means it's increasing. Okay? If dy dx, if your first derivative is less than 0, it means decreasing. Okay? And then if your slope equals 0, what does that mean?
Flat.
It means turning point or maximum of the graph. Okay? Now, if your graph isn't a minus x squared, so I just need to do one other one for you now. From here, okay? Now, right here is the graph of y equals x squared minus 5x plus 6. Now, what you'll notice about this one is it has a plus x squared, not a minus x squared. This plus x squared means that it's a U-shaped graph. Do you understand? It doesn't have a maximum point, it has a min. You can identify if your turning point is a maximum or minimum by the start. Okay? So what you can do is, there's two tests, alright? So what we can do here is, as we said before, it's on its way down, which means it's decreasing. Then after the maximum point, it's on its way up. So for example, if I differentiate it, what am I getting when I differentiate this? Again, 2x minus 5, but what does that 2x minus 5 represent? Represents the slope. So for example, if I replace x with 6, or sorry, x with 0, it's actually y equals 6, x equals 0. If I replace x with 0, are you expecting a downward facing slope or upward facing slope? You're expecting a downward one, a tangent there, okay? So what happens is we put in x equals 0, we get 2 times 0 minus 5, So we're going to get dy dx equals minus 5. That's a downward curve, okay? If I put in, let's say, x equals 4, what would I be expecting? Upward, a positive value. Now guys, sorry? Oh, sorry, I didn't use the 6. I'm only ever using the x values. It's 0, 6. So the y value is 6, but the x value is 0. That's why I use x equals 0 for that. How do I know x equals 0? Because it's on the y-axis. X is always 0 when there's a point on the y-axis. Okay? For example, if I use this point here, David, see the point I just had a dot in here? Okay, this is the point x equals 2. Alright? So I have to use the x value, not the y value. The y value here is 0, but I always use the x value because the equation says x is not y. So that's what we're doing. So if I place 2 in there, I'm going to get 2 multiplied by 2 minus 5, which is minus 1, which is a negative slope. That's what we're expecting, isn't it? Okay, now guys, yeah.
Sorry, you're so in.
2 things you need to do, okay? First thing is you differentiate, and what do we say this is again? The slope. Do you understand? It's the slope, okay? Now, there's a second test, alright? And the second test is a quick way to tell if you're dealing with a maximum or a minimum. It can ask you this on occasion, okay? If you differentiate twice, now that's how you write down you're differentiating twice, okay? And if you're differentiating twice, okay, what happens is, thank you. Okay guys, the second derivative, okay, excuse me, the second derivative tells you if it's a positive or a negative. Now, oddly enough, the second derivative works exactly the opposite of what you think it should. If the second derivative is bigger than 0, it means it's a minimum point, as in it looks like it's a U-shaped graph. If the second derivative is less than 0, it's a maximum. So let me show you what happens. If we differentiate this a second time, what do we get? You just get 2 and 0. 2 is bigger than 0. This means it's a minimum point, and we can see that from the graph. Now, if I go back one step to my last equation, which was this one here, we all know it's a maximum by the shape of it, don't we? And if it's a maximum, okay guys, what we can have is this. We can have it's minus 2x plus 5, differentiate a second time, and what do we get? Minus 2. Minus 2, smaller than 0, maximum point. Okay guys, so in a nutshell, that's the way you usually get an N-shaped or a U-shaped. Now, what we get here is the following, okay? A farmer is growing winter wheat. The amount of wheat he will get per hectare depends on, amongst other things, the amount of nitrogen fertilizer he uses. For his particular farm, the amount of wheat depends on the nitrogen in the following way. Y equals 7,000 plus 32n minus 0.1n squared. The way I want you to think of this is an equation like what we just dealt with a second ago. 7,000 plus 32x minus 0.1x squared. What I want you guys to tell me is this an N-shaped or a U-shaped graph? The letter that's squared, does it have a negative number in front of it or a positive number in front of it? Negative. It means when you were to draw this out, it turns into an N-shaped graph, which means it has a maximum, not a minimum. Now, what this graph is basically doing is, guys, you're going to end up drawing, this equation represents a graph on x and y axis, okay? What happens is, the y-axis is the letter y, okay? And the letter y is the amount of wheat. So the amount of wheat is on the y-axis, and it's pronounced y. And the amount of nitrogen you use is on the x-axis. So whichever letter is on its own is the y-axis. Whichever letter is not on its own, as in there's a couple of numbers beside it together and there's a squared, that means that's the x-axis. So basically, as I use more and more nitrogen, what happens? At the start it goes up, 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 reaches a maximum point in which the nitrogen gives you the most wheat. Then if I add in any more nitrogen, I actually get less wheat. That's what we're looking to do. Okay? So, that's the full equation explained. So the first thing it's going to ask you is, y represents the number of wheat you get, and Y represents the number of wheat you get produced in kilograms per hectare. Please read that it says kilograms per hectare. Okay? N is the amount of nitrogen added in kilograms per hectare. How much wheat will he get if he uses 100 kilograms of nitrogen? Well, the wheat you get equals 7,000 plus 32 multiplied by 100 minus 0.1 times 100 squared. So you're just going to put that directly into the calculator, and what we're going to get is, we'll get is 9,200 kilograms per hectare. Okay? Only because it tells you to use that language. What we're doing next, guys, is find the amount of nitrogen used in order to maximize. Keyword there is maximize. Remember I drew that graph earlier, and I said the max is what's called a turning point. In a turning point, your slope equals 0. This means if we get the first derivative, when we get the first derivative, we then figure out what the equation for the slope is. Now, usually if I had y equals x squared plus 5x, when we differentiate, we write dy dx, because the letters are x's. If I change all these x's to n's, what would the differential turn into? Dy dn, because it's in terms of n's. Okay? So look at this, guys. We differentiate like we did x earlier. What does a regular number turn into? 0. What does regular number turns into 0. What does 32n turn into? 32. Same as 32x. What does 0.1n squared turn into? Or what would, more importantly, what would 0.1x squared turn into? Bring the 2 to the front and multiply it. So it'll be 0.2x. Remember we differentiate x squared earlier, David. You multiply the 2 by the number in front, and then you take 1 away from the power to get 6x. In this one we're multiplying 2 by 0.1, which gives us 0.2. Take 1 away from the power, and you get x. Or in this case it's n.
It's not minus 0.2.
It is minus 0.2 anyway, because there's a minus n squared. Okay?
kg or LXG?
Kg per hectare. Okay? Next thing, guys. What we're doing next is, it goes, we know that this is the equation for the slope, okay? And what we said is for a turning point, the slope has to be 0. So, and the question's asking us, what amount of nitrogen do we need? Which letter is nitrogen? How much nitrogen? N. We need to get N on its own. 32 equals 0.2 N. Then divide it by 0.2. So 32 divided by 0.2, I think it's 160. So N equals 160. Now what's N measured in? It says at the start, kilogram per hectare. It's going to be 160 kilogram per hectare. Okay? Okay, so when you get 32 divided by 0.2, gets you 160 kilograms per hectare. Move on, next part. Okay, it says, what is the maximum possible amount of wheat produced? The number of wheat produced is the y value, and the y value is, what is it, 7,000 plus 32n minus 0.1n squared. Now guys, what we found out in the last question is that the maximum occurs when n equals 160. So if we replace n with 160, what should happen is we should find out how much wheat we'll get when we use 160 kilograms worth of nitrogen, okay? So it's going to be 7,000 plus 3 times 160 minus 0.1 times 160 squared, and what we get is 4,920 kilograms per hectare. Okay? Sorry guys, it's 32. So if you just quickly change that, what happens is we're using the original formula. which is 32N. Thank you. And what we should get is 9,560 kilograms per hectare. Now guys, what it's saying next is the farmer's total cost per producing the wheat are €1,300 per hectare. So it's looking for profit. Profit equals your sales minus your costs. Okay? So what it says for sales is that he can sell the wheat for €160 per ton. Now, a ton is 1,000 kilograms. 1,000 kilograms equals €160. We have to find out how much 9,560 kilograms is worth. So what we can do is we can divide by 1,000. When you divide by 1,000, you find out how much 1 kilogram is worth, and then you can multiply by 9,560 to find out how much 9,560 is worth. So you're going to get 160, and you're going to divide it by 1,000. 160. You're going to divide that by 1,000. Then once you've done that, you're going to multiply by 9,560, and what you're going to get there is 1,529.60. 1,529.60. That's our sales. Now it also says that we can make money from selling the leftover straw. So we can add on €75 to that. Okay. So 1,529.6 plus 75. What that will give me is 1,604.6, and then we have to take away our costs, which is 1,300. Take away 1,300, and what we get is our profit per hectare is 304.60. Okay.